All right, physicists, I hope you're watching this video before you do your homework on Wednesday night, October 7th. The homework is going to look almost like the homework from Monday night. The difference is I've added in a few more questions to lead you slowly to the answer. Some of you are making what would be called silly mistakes. So you were looking at a velocity graph, but you were treating it like it was an acceleration graph, or you were looking at a position graph and treating it like it was a velocity graph. That is not going to work. So if you're looking at a position graph, basically a position graph can show you two different things. So here's a position graph. And on a position graph, you can tell things about the position. You can tell the initial position. You can tell the final position, right? That's what a position graph tells you. But it also tells you things about the velocity. So we know that if you're looking at a position graph and you have a line like that on the graph, if you find the slope of that line, then you will know the velocity at that exact instant on the velocity graph. So a position graph can tell you the position, and a position graph can tell you the velocity. Now, when you move to a velocity graph, on a velocity graph, obviously, if you have a line on the velocity graph that looks like this, and again, right now, don't get confused. These aren't related. I'm just making up an example right here. So if this is what your velocity graph looks like, there's things that you can tell about it. If you want to know about the velocity, you can find the final velocity, you can find the initial velocity, you can find the change in velocity. All of that information is on the velocity graph. But if you find the slope of the velocity graph, it will tell you the acceleration. And if you find the area underneath the curve in the velocity graph, that will tell you the change in position. So the velocity graph, since it's the one that is usually in the middle when we write it down, the velocity graph can tell you two things. Finding the slope of the velocity graph will tell you about the acceleration. Finding the area underneath the curve on the velocity graph will tell you the change in position. Finally, if you have an acceleration graph, on an acceleration graph, if you have a line that looks like this, and you find, well, first of all, it can tell you about the acceleration. It can tell you initial acceleration, final acceleration. Since we're learning uniformly accelerated motion problems, our initial and final acceleration will always be the same for this kind of problem that we're learning right now. But if we take that acceleration graph and we find the area underneath the curve, it will tell us the change in velocity. So quickly reviewing one more time, if you have a position graph, you can find out the things like initial position, final position, change in position. Also, if you find the slope of the position graph, it will tell you the velocity. If you have a velocity graph, you can find out initial velocity, final velocity, change in velocity. If you find the slope of the velocity, it will tell you what the acceleration is. And if you find the area underneath the velocity curve, it will tell you the change in position. Finally, when you're looking at an acceleration graph, if you know the area under the curve, it will tell you the change in velocity. So, number one, make sure you know what kind of graph you're looking at. Number two, make sure you know how finding the slope will tell you the velocity, finding the slope will tell you the acceleration, finding the area will tell you the change in velocity, finding the area will tell you the change in the position. And then finally, probably the silliest mistake of all is not looking at the scale on the X and Y axis. So if you look at the time axis, the X axis, you need to know, are they counting by seconds, 1 second, 2 seconds, 3 seconds, or is it counting by 5 seconds? Is it counting by twos? Same thing when you're looking at the y-axis, if it's position or velocity or acceleration on the y-axis, what are they counting by? Does it count by ones? Does it count by 20s? If you don't know that, you're not going to be able to do any calculations involving the graph because you'll be using the wrong numbers. So it's very important that you understand these things before you take the test on Friday. Number one, know what kind of graph you're looking at. Number two, know how to get from one graph to the next. What information does each graph tell you? And number three, make sure you know the scale on each axis.